In this question, we're given the wavelength that channel 15 transmits its radio signal, and it has a frequency of 476 megahertz. And we want to know the wavelength of this radio wave. So in order to do this, we need to use the relationship between frequency and wavelength. So c, the speed of light, equals lambda, this is the wavelength, times nu, and nu is the frequency. So c is the speed of light, and it is 3.00 times 10 to the 8 meters per second. You may see it as 2.998 meters per second or 2.9979 meters per second. That's just more significant digits, and certainly you can use more significant digits. Lambda is the wavelength, and that's in meters. And the frequency is nu, and it's in hertz or seconds to the -1, but here I'm just going to put it as hertz. So now we have the equation that we need to do to solve this. Because this is a constant, if we know one of these two things, we can find the other. But before we do that, we need to rearrange it. So we're looking here for lambda, so we have to divide both sides by nu. So lambda equals c over nu. So this is the equation we actually want to use because we divided both sides by nu. However, we can't plug everything in directly. So we can plug in the speed of light, it's a constant, 3.00 times 10 to the 8 meters per second, divided by nu. The frequency has to be in hertz, but the frequency is given in megahertz, so we need to change the units using dimensional analysis. It turns out that 1 megahertz equals 1 times 10 to the 6 hertz, or 1 million hertz. So, in order to figure this out, what we need to do is take our 476 megahertz times, we need to put 1 megahertz on the bottom so it'll cancel out, and 1 times 10 to the 6 hertz on top, the million hertz on top, and when you do this you get 4.76 times 10 to the 8th hertz in scientific notation. I'm running out of space here, so I'm going to shift this over a little bit, but basically we can now plug in our frequency, 4.76 times 10 to the 8th hertz, and when we do the math, the calculator gives us 0.630251. However, this is 3 significant figures, this is 3 significant figures, so our answer should be 3 significant figures. Since it's a 2, we want to keep it constant, so it's 0.630 meters, which is the wavelength of the 476 megahertz TV signal.